So we're going to try part A, sketch the graph of r of t, use arrows to indicate the direction that t increases. In other words, use arrows to indicate the orientation of the curve. So, okay, this one shouldn't be too bad. If we just do part A, let's make a chart. You could maybe eliminate the parameter too, but that's not always possible. So let's use, let's use t, x, and y. What would be some good t values to plot? 0, but I'm going to put that down a ways. Maybe -1. We could even go -2, right? 1 and 2. Okay, let's get the x components. What do you get for x? So x is t squared, right? And y is t. What do you get for x when you apply to the squaring function? So you're plugging in these values into the parametric equation. So, okay, so I plug in -2, I square it, I get 4, right? So it's the squaring function. Oh, you just square all these. So 1, 0, 1, and 4. Yeah? And then y is t, so that's easy. Just copy down t. And so you graph these coordinates, right? What is this going to look like? Any predictions? It's going to look like a parabola? Did I hear a sideways parabola? Well, yeah, not if I turn my head like that. So, okay, so I'll go out 1, 2, 3, 4. So it certainly goes through 0, 0, and then 1, 1, 1, -1, and then 4, 2, 4, -2. And that's how I chose to draw it. How is it actually drawn? As t goes from negative to positive, it starts at 4, -2, right, down here, and then kind of goes this way, right? Kind of a, I guess, clockwise fashion, right, as we're looking at it. Does that make sense? How could you eliminate the parameter on this if you wanted to? So realizing that in parametric form, parametric equation form, x equals t squared and y equals t, what could you do to eliminate the parameter? Right there, right? X equals y squared. Oh, yeah, that's the sideways opening parabola, vertex 0, 0, right? The simplest one. There's lots of others. If you go to mode on your calculator and go down to the fourth guy down, or the fifth guy down, one of them, instead of being in function mode, change to parametric mode. Arrow over, hit enter. And then this is a really nice way to graph non-functions on your calculator in parametric mode. So we can just type in x equals t squared for x1, and at y1 is equal to t. So we're essentially plugging in the parametric equations. If you just graph on a standard screen, like if you hit zoom number 6, you won't get the whole thing. Because for whatever reason your calculator starts t at 0. But there's no restrictions on t in this one, so if we start t, let's just go from -10 to 10. And you hit graph, and you get the full parabola. And if you're in function mode, it's not going to graph that using one equation for you, is it? Because it doesn't pass the vertical line test. It's not a function. So that's pretty handy. And then we'll keep that open. Okay, so for this guy, for part B, I think eliminating the parameter is the easiest way to graph it. What would the parametric equation be for x? Well, okay, the easiest way to graph it is on your calculator, like I just did. 2 cosine t, and let me erase this other stuff too. And then what's y? 3 sine t. Now, I didn't put restrictions here, but there's no reason to let t go beyond 2 pi. So from 0 to 2 pi would be the natural way to limit t, because anybody remember what this is going to graph to be? An ellipse, right? And the entire ellipse will be carved out over the period of sine and cosine, which is from 0 to, well, there's lots of different periods of it, but the one we usually talk about from 0 to 2 pi. And then what you do is you solve for cosine, solve for sine, and use a trig identity. Remember that? So if you take this equation and solve for cosine, what do you get? Cosine of t is equal to x over 2. Take this one, solve for sine of t. Sine of t is equal to y over 3. And then you plug it in your favorite trig identity, assuming your favorite trig identity is what? Cosine squared plus sine squared equals 1. So what do you plug in? You plug in this guy is cosine, right? So you take that guy, you square it. That's cosine squared. This guy is sine of t, right? You take that guy, square it, and that's sine squared, and we know that it equals 1. And then if you rewrite this, if you square the numerator and denominator, x squared over 4 plus y squared over 9 equals 1. And that's an ellipse, right? What's the center of that thing? 0, 0. And then, so you plot, well, you know where 0, 0 is at, but normally you plot the center, and then you go left and right. How far? 2, a distance of 2 from the center. Go up and down. How far? 3, a distance of 3, the square root of the number underneath y squared. You go up and down that distance. The square root of the number underneath x squared, you go that distance, right? And then you draw the best oval shape you can. That's an ellipse through those 4 points. So it goes longer on the y, right? So let's say for the sake of argument then that's, let me try and get the center right there. Close enough probably. Not perfect, but close enough. So the idea is that this point right here is at 0, 3, and this point on the ellipse right here is not 0, 2, but 2, 0. And then, negative 2, 0, 0, negative 3. So his question is, how do you parameterize it? Well, you could always just plot a couple of values and see which way it's going, right? So t, and then the x in terms of t, which was what, cosine? No, it was 2 cosine. 2 cosine. 2 cosine t, and then y was 3 sine t. So what would be a couple of good t values to plot? 0 and how about pi halves? Yeah. So if you plot 0 for t, what do you get for the x component? 2. Cosine of 0 is 1 times 2 is 2. If you plot 0, and what do you get for y? Sine of 0 is 0 times 3 is 0. If you do it for pi over 2, the cosine of pi over 2 is 0. The sine of pi over 2 is 1 times 3 is 3. So you can see it goes from 2, 0, 2, 0, 3. It's traveling in a counterclockwise fashion. And it'll do that all the way around. It's not going to change all of a sudden. Does that make sense?